Hi, this is Gravitational Fields 2b. So you should have gone away and drawn those three. If you haven't, pause this now, actually go and do it. Okay, so first one, near flat Earth. Let's think about what the gravitational field lines are going to be. Well, let's just choose a point. So if you're a test mass there, where are you going to be pulled? We're going to be pulled straight down. So you just draw a line straight down with an arrow pointing down. If you're a mass here, where are you going to be pulled? Exactly the same, straight down, little v. Where are you going to be here? Straight down, da da da. We want them equally spaced because we're assuming the gravitational field strength is similar, and that's how we draw that. Simple. Round a mountain, little bit more complicated. If you're here, you're not really going to feel the mountains, you're just going to go straight down, and that's easy. Same here. When you're close to the mountain, if we imagine you're far away, you're just going to be pulled towards the Earth, but then there's actually going to be a little bit of extra gravity in the mountain pulling you towards the mountain. So there's going to be a line that's going to curve inwards because the force is going to be straight down, but as you get close to the mountain, it's going to pull you towards it. Exactly the same on the other side. And then if we imagine the field line here, that's actually just going to go straight down towards the top of the mountain. So we just get pulled a little bit towards the mountain. If you imagine an asteroid was hurtling down, it would bend ever so slightly towards the mountain. Now these curves in real life are going to be extremely subtle because if there's an entire planet here, gravity in the planet is much stronger than gravity from the mountain, but you can sense that. If you put a pendulum near a mountain, it will actually be pulled ever so slightly towards it, and you can measure that. Some of the earliest measurements for G, the force of gravity on Earth, were in fact made by putting pendulums near mountains. So that leads us on to the third and most difficult, the field lines between two planets. So if we draw two planets, make them the same size, make them easier, here and here. Now what we've got to do is exactly the same thing, consider what the force will be on a test mass. We've just got to consider it in a greater range of scenarios. So if your test mass is here, simple, you're just going to be pulled towards the planet like that. Exactly the same here, 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 and here. No problems at all. The difficulty comes in when we consider the area between the planets. What's going to happen here? Well, if we imagine a mass all the way over here, it's going to be pulled towards them, and then it's actually just going to sort of deflect towards this planet. Same over here, same here, same here. But what about this area in the middle? Well, I said the field line represents the resultant or overall force. So therefore, we'd expect there to be a point in the middle where there are no field lines at all. Because if you're right in the middle of the distance between these two planets, the force pulling you one way and the force pulling you the other way are going to completely cancel out. So there's actually going to be a region here with no force on you at all. And we represent that by drawing no field lines. So what we can do is we can put in another couple, sort of one going like this, and one like this, and one like this, and one like that, because there's a mass came up here, it would arc towards these planets, and then a little region in the middle with no force lines. These little regions here are present between any two astronomical bodies, and they'll be closer to the heavier one. So if you consider, if you were on the moon, and you blast off the moon and started flying towards Earth, there'd be a point closer to the moon than to Earth where you wouldn't be being pulled towards either, because the gravity from the moon and the gravity from Earth would cancel each other out. There are some between the Earth and the Sun, so on and so forth. There are lots of these sort of little weightless points in space between two masses. So that's how we draw the field line between two masses. Right, I've shown you how to draw field lines. There's some more questions about drawing field lines under this. Answer them and email them to me by midnight on Wednesday. Best of luck, see you later in the week.